For those of you guys just joining us, there were a couple mistakes on the answer key on Google Classroom. I will scan the new, nice and improved version for you to access. I mean, it's a little too late, but for you guys to look at. But we're going to look through the mistakes really quickly. First of all, I did a cylinder, not a cone. This needs to have a 1/3. So I threw in a 1/3 this morning in period 1. That made that 125 pi over 12. I don't think those reduce. I threw in a 1/3 to my volume work down here, which amended, changed a little bit my answer in that instead of being over, I think it was over 40, wasn't it? And then you were able to reduce it. Instead, it was over 120. And so reducing that, the final answer for letter B should have been negative 15/8 pi. That's a centimeters cubed per hour. I know, I'm sorry, the bus. But volume, time. Volume is cubed, time is hours. And then that changed just a little bit down here as far as when, now this was just translating from the problem. Directly proportional to is k times. Inversely would have been k over. To show this is true, I just went ahead and got everything in terms of r. I needed to throw a 1/3 in front, so then there were a few thirds that happened. I did some changing, some amending. You end up still with a constant times pi r squared, just the constant should have been negative 3/10. Does that match up with those guys that figured out it was a cone? Never mind. Any other mistakes in that number 99 that you guys want to address? Never mind. Okay, so let's go up to number 98. Number 98, I don't know what I was doing when I answered this one with a closed interval from 0 to 28. But decelerating, acceleration is negative, so velocity prime is negative, so slope of velocity is negative. All of that was good, and then my answer did not match up. I think I got distracted. So you were looking for when velocity prime or slope is negative, which is also when velocity is decreasing. So when is velocity decreasing? From 10 to 28. Open interval, because question, what are the slopes at the sharp points, the sharp transitions, the sharp turns? D and E. So it couldn't have been a closed interval anyway. And also, velocity is not decreasing at the sharp points. It's a transition from staying constant to decreasing to staying constant. Anyway, velocity is decreasing, aka acceleration is negative between 10 and 28. Open interval. Anything else you guys saw in numbers 93 to 98? They didn't find any other mistakes, but just in case. Okay. Moving backwards, I think the other mistake came around, oh, where was it? It was the midpoint approximations because I did the wrong interval. Did you guys find that? Here we go, number 73. I was going fast, and as I was going fast, I was like 0, 2, 0, 2, sweet, 0, 2. Split it into midpoints, 1/4, 3/4, 5/4, 7/4, and I was like, yay! And then I was reminded this morning, no, it was from 0 to 4 of a totally different function. Awkward. I assumed what the problem was instead of reading it. So I needed to go from 0 to 4 in 4 jumps, which means my base is 1, not a half. These ones it was jumping by a half, but now I'm jumping by 1s, hence my base is 1. And then the midpoints of these subintervals will be 1/2, 3/2, 5/2, 7/2. Plugging in this function. Guys, you know why I wasn't writing A1, A2, A3, A4, because there wasn't space, right? But how was I able to write all of this and just write an answer? What was I using? Yeah, same thing Jack's using right now. How do I do this quickly, efficiently? I'm going to use my Y1. I'm going to throw into Y1 the absolute value math over abs or alpha. Where's all that cool stuff? Alpha window? Right? Is that where the abs and the sum and the integral and the derivative is? Yeah, alpha window. Either way, y1 is equal to the absolute value of x minus 2, not the integral. The integral is being approximated with area. No, just absolute value, x minus 2. And then how do we find y1? Isn't that alpha? I bet I still have it. Do I still have it? Oh, I don't. I went to parametrics. I let a kid borrow it. Hold on. Let me see if maybe it's still here. Is it still here? Yeah. See, there it is. Back when my y1 was what it was supposed to be, then you were able to go ahead and throw in 1 times y1 of 0.5 and 1.5 and 2.5 and 3.5 and 4.5, all using alpha trace. That little, oh, sorry, I'm in parametric mode. Awkward. Alpha trace. There you go. My y1s. And then there's our little absolute value alpha window, the little abs that you can use in plugging the function into your y1. Oh, there he is. Look how happy he is. Okay. Any other questions on the Riemann sums? I think I got them. I thought there was one more mistake, but oh, yep. Number 57. Another one of those. I don't know what I was thinking. I think it was like midnight on Thursday. You guys have those moments too, right? Ew. Sorry, that looks funny with the whiteout. G is increasing when G prime is positive. G prime is positive. G prime is positive, aka above the graph, because Y values are G primes. Above the axis, I should say, from -2 to infinity. I had it backwards. I had it backwards for whatever unknown reason. I think I was thinking decreasing. The derivative is below from -infinity to -2, so decreasing, but increasing is everything else. Sometimes faster, sometimes slower, sometimes stopping, but we can say that entire interval. We can say that it's increasing. You could have split it up at 1 if you really wanted to. It's an instantaneous stop because it's 0. The derivative is 0. But technically, they're okay including it. I don't know why. It is a common AP practice to include it when it's positive before, positive after. If it was dne, if the derivative was dne, we'd have to split it up, but otherwise, no. I think, just remembering who was asking me questions this morning and what things they thought I had made a mistake on, I think I've gone through all of theirs. So before we go to just what you have questions on, is there anything else that didn't measure up, that didn't seem to make sense, where it seems like I did something illegal or I did a different question or a different problem or a different interval? I answered it backwards. Which one? 62? 62? Oh, I just didn't finish it. I'm sorry. I meant to go back to that one, and I forgot that I had left it blank. That's a good question. Thanks, Lorenzo. In number 62, whoop, whoop. Why did I leave it blank? I didn't have my calculator on me on the time. Why was I going to come back to it, even though I forgot to? What's the part that's missing? So far, I've taken my derivative implicitly. I did my product rule legally. I took the derivative of 10 like I'm supposed to, which is 0. But then what was I supposed to do? Find the y value. How do I find the y value? Well, hold on. What's x? 2. And I didn't even look to see how hard the equation it was. That was me being lazy and going fast. So if we were to plug in 2, couldn't we say from the original equation 2 squared plus 2 times y is equal to 10? I was totally assuming this was going to be worse. Didn't even look at it. Can't we solve for y by subtracting 4 to be 6 and dividing by 2 to be 3, so y is equal to 3? They didn't tell it to me, but I was able to find it. And once I find y equal to 3, can't I come over here and plug in? When x is 2, finding y, we found y to be 3, so I can plug and chug. And the last step is to go ahead and get dy dx by itself. So dy dx is equal to 4 plus 3 is 7. Subtract the 7, divide the 2. Lorenzo, how does negative 7 halves look? Good? Cool. Is there anything else that was incomplete? Maybe I should add that to my list. Incomplete or confusing or possibly illegal. Did I leave any other ones blank? 51? 61? Oh, bottom of the page before. 61, 91, 92. 61. Oh, I sketched the graph and never came back? Oh, you guys. Silly, silly, silly. I'm sorry. I was having too much fun. Local extrema. I have a relative max at 1, 2, 3, 4 because the derivative changes from a positive to negative at that point. So I have a relative max. Oh, I'm so sorry. There you go. The derivative changes from positive to negative, which means f changes from increasing to decreasing relative max at x equals 4. They just say the x coordinates, so I don't have to go find the y's, which is nice. I'm not sure if I could. Nope, don't think I could. Justify your answer since. Now, if you said f prime changes from positive to negative, you would have been half right. If you said f prime changes from increasing to decreasing, you're all wrong. If you said f changes from increasing to decreasing, you would have been half right. Why am I saying half? What else do we need for a relative extrema besides a sign change of the derivative? It needs to happen at a what? Critical number. I have to also say f prime of 4 is, remember, critical number is a 0 or a DNE. A DNE is okay as long as and if you guys look at the beginning givens, didn't it say that f was continuous? So f is continuous. This point exists. The derivative does not, but the point does. That must be like a sharp point. Oh, it is a sharp point. That is allowed to be a relative extrema, and according to the graph, I saw it too. So it was in the graph, sorry, I just didn't actually write it out. And then points of inflection, I think there's only one, because the second derivative only changes sign at one place at a pip, which is at 2. So the point of inflection is going to be at x equals 2, since f prime, double prime, of 2 equals 0. So it's a pip, and there's a sign change of f double prime at that point. You could be specific and talk about how the sign change of the second derivative means a concavity change of f. You can talk about that, but that's sufficient. That's enough. Jack, what were you saying? 90, 91? Oh, I came back to it on my secondary version. Sorry, I came back to it. It just took me a little bit. Anything else? Incomplete, missing, didn't get the final answer down? Any other mistakes? Okay, so now no one's questioning any of the solutions as to whether or not I'm right, but my question is, do you know why I'm right? Are there any that you're like, okay, I think you're right, I just don't know why? Kevin? 99C. 99C. Okay, I was talking about related rates. This one was all about the wording, so it's just translation. So remember when we read rate of change of volume due to, oh, they don't even say with respect to time. But yeah, you can go ahead and just say rate of change of volume in context of the problem is dV dt. Is equals directly proportional to this wording right here, and I said it real quick a second ago, but I didn't show it. From algebra, directly proportional means k times something, and inversely proportional, is k divided by something. So literally they were telling me, hey, some constant times when they said directly proportional to, and then directly proportional to what? The exposed surface area of the water. Well, if you look at the picture, the exposed surface area, isn't that just a circle? An area, well, that's pi r squared. Oh, now I just lost my r. That's kind of sad. Anyway, boop, boop. That's why I went ahead and wrote out this expression of dV dt, actually equation, equals k times what? Exposed surface area is the area of a circle, pi r squared. So I was supposed to show that was true, but in all this work up above, my volume was in terms of h's because that was the clue that I had to plug in. So everything was with h's, and I was like, oh, stink. Well, if they're asking me about r's, I need to go back to the beginning, and I need to make it in terms of r's. So instead of substituting for r in terms of h, I had to come over and think about, okay, wait a minute, no, I want my r's, so I need to go ahead and say h is equal to 2r. Let me come over and plug in 2r for h. And that's what I did. Then I went ahead and simplified to get my volume expression, but they're saying rate of volume, so I had to go ahead and take a derivative of this. Bring down my 3, my 2 pi r squared dr dt. But they didn't give me a clue for dr dt. No, but they did give me dh dt, and they gave me a relation, or a relating between r and h. So technically I did this in my head. I'm sorry, maybe I should have shown it. Oh, no, I didn't. I did it right here. Maybe I should put it in parentheses. I came up here and I said, well, fine, if r is equal to h over 2, then I can take the derivative of both sides. The same way I can take the derivative of all of these guys, I can take the derivative of that guy. And I can say dr dt is related to h in that. No, I rewrote this to make my life easier. Thought of it as 1/2 h. But dr dt is equal to 1/2 dh dt. With that expression, I can plug in my negative 3/10. I can then plug in that whole expression into my dr dt. My 2's canceled. Negative 3/10 pi is my, ooh. No, that's right, sorry. K is apart from the pi because pi r squared is the exposed surface area. Yeah, K needs it. I was almost going to say your coefficient is negative 3/10 pi, but no, the pi needed to stay with the r squared. So my extra constant is just negative 3/10. And that's just showing like, oh yeah, I can find the K that you tell me relates, so that means I'm good. Okay. Something else. You're like, I don't know why.
How do you start 100A?
Yeah. 100A.
100B.
Either way. 100 in general, guys, I would call this, and I think it's in, is it in your cheat sheet? I think it's in your cheat sheet. I think it's the very end of your cheat sheet. Hold on, let me see. Do I have the cheat sheet here? Yeah, I do. Let me zoom out a little bit. Are there some word problems at the very end of your cheat sheet? Or am I going crazy? No. What am I thinking of right now? Related rates optimization. I think I'm missing a page in this one too. I might just be thinking of this problem. Okay. This problem is what I would call adding and removing. There's some sort of coming in and going out. You live in California, so you should be more prepared to be able to do these types of problems than anyone else. Because what kind of problem is it? It's an in and out problem. Why? Something's being added, something's being subtracted, something's being put down, something's being picked up, something's falling from the sky, and something's being shoveled off the driveway. Some ones are coming into the park and going out of the park. This is an in-out problem. Now, in in-out problems, they can give you different stuff, but in this one, what was given to you in the beginning, I saw the word rate. In and rate out. See the in and out? How fast going in, how fast coming out. So whenever they started talking, like in letter B, about the actual level of oil in the tank, not coming in, not going out, but residing in, it's the combination of the two. If you have a water hose that's flowing in to a pool that has a leak, aren't they combining to affect what's actually in the pool itself, right? The water hose is trying to add the water, and then the leak is trying to subtract the water. Well, it's subtracting the water. So if I'm trying to think about what's going on in the tank, what the level is at in the tank, it's a combination between the two. But hold on, wait. Rising or falling, isn't this looking at the derivatives of the level of the oil? Rising or falling is like increasing, decreasing. It's like looking at the primes. Wait, who are the primes? These guys. This is the rate of how fast coming in, gallons per hour, the rate of how fast going out, gallons per hour. So all I need to do is plug in the time, 6, to say, hey, is it coming in faster or going out faster? And if it's coming in faster, won't the level be rising? If it's going out faster, wouldn't the level be falling? There are different ways of doing it. I just like making a mathematical expression and saying, hey, you want to know what's going on with the level? You got to look at the rate of the level, and that's h minus r. How fast coming in minus how fast coming out. And I just decided to make it a letter so I could refer to it later if I needed to. So I just said L for level, whatever. Maybe I should have called it L prime, but oh well, too late. So I went ahead and plugged and chugged, and when I plugged and chugged, I went ahead and got a negative number, which meant who was stronger, in or out? Out. So therefore, the level must have been fallen, like decreasing, because it's negative, it meaning the rate of the level. Did you want me to keep going at all, Hannah? C? Okay. So then letter C says, how many gallons are in the tank? Is this how many are coming in, how many are going out, or how many are residing in? Residing in. So I need to go ahead and once again factor both of these guys. But guys, how do I get from gallons per hour to gallons, from rate to original? I need to integrate. But integrals, if I need to know not what's happening over a time interval, but how much is present at a certain time, this is integration as net change. I need to know how much is at, which is why you should see in my letter C work something about the final amount or the amount at 12. And I had used L to be a rate, so I had to make a new letter. I was kind of annoyed at myself, but oh well, it didn't have whiteout. So L was a rate, awkwardly. So then I made G being how many gallons are residing in the tank. And here's my integration as net change. G of a time is equal to G of an initial. So the final amount is the initial amount plus whatever change has occurred in the amount over this time. So the amount at 12 will be how much you've started with, 125 gallons, plus whatever has ended up occurring over those 12 hours. And if you guys can tell, over those 12 hours, what ended up occurring was actually you lost a few gallons. Even though you were pumping in, there was stuff going out. So that was the overall effect, where you started plus the displacement or plus the change that occurred. Is that cool? Then letter D is super similar in that once you have figured out that this G guy is how much oil is in the tank, I just need to find his absolute min. So to find his absolute min, you guys should have seen me testing critical numbers and endpoints. Endpoints are 0 and 12. Critical numbers, I had to go ahead and actually find my critical numbers by, well, I could have just used, anyway, my notation was getting confusing here, but I needed G's derivative, aka L, to be 0. I needed the derivative of the combined effect to be 0. Wait, guys, how did I magically get decimals? I calculated. Didn't I do y1 minus y2 and I found the zeros between 0 and 12? Are we okay using our calculator to find zeros? We've talked about this, yeah? You could do intersections, but they could be up nose, who knows where. If we just say y1 minus y2 is our y3, sweet, let's go find the zeros. And I found 2 of my zeros. I even knew who was a relative max and who was a relative min. But last year, you want current events? Last year, on the FRQs, it was a topic of debate, and a lot of teachers were mad at the math conference I went to last semester with Mrs. McRae. An AP reader was like, we took off a point if they did not test, even though this is a an absolute min, they took off if the students did not also test the relative max in the table. Even if the student said something like, what, the derivative's changing from positive to negative, it's a relative max, of course it's not a relative min. Don't ask me why. There were a lot of teachers that were mad. I was super perplexed and like, what the? Because it's like the relative max, it's no way it's an absolute min. Oh well, too bad, so sad. Throw into your table the endpoints and the critical numbers. Find the lowest dude, he's the absolute min, or find the highest dude, he would be the absolute max. I'll just give you justification in between. Is there anything else you're like, I didn't know what you were doing or why? Okay, here's what we're going to do for the end of class. Didn't I tell you there was a bonus? There is a bonus practice exam online 2003 underneath your exam folder. And that's technically due by Friday if you want to get it in. Doesn't mean you can't do it later. You just won't get bonus as a result. However, and we'll talk a little bit more about deadlines tomorrow. We're just running out of time today. In that some of you aren't taking the mock AP on Saturday, We have people going to France. We have people who are doing like a UCLA Bruin visit day because they're very possibly going there next year. There are a few different valid excuses, and some of you might have some valid ones as well. Tomorrow I'm going to go ahead and pass around the sheet as to whether or not you are committing to this Saturday or next Wednesday. Doesn't mean that some life event might keep you from coming Saturday. It better be a good one. But I need to plan ahead because there are different versions. Like I'm doing completely different exams just to be fair, so that whoever is taking it on whatever day, it is a brand new AP exam to them. It's the only way to be fair. So I need to plan ahead because the office needs to copy off a lot of stuff for me. So tomorrow I'm going to be passing around that. So if you haven't decided or talked to your parents about this Saturday, even though I've been warning you for months, August, but the date changed. You need to figure that out. Okay. But also, not only is there a bonus practice exam, but there was also, I warned you, a required practice exam. AP exams come in 4 parts. Calculator multiple choice, non-calculator multiple choice, calculator FRQs, and non-calculator FRQs. I have for you calculator. Pause. Calculator multiple choice. If I have for you calculator multiple choice, I hope there's enough, it seems small. Pause. Each night this week, Monday through Thursday, you're going to be given you have minutes, 5, 0. Timer. Do the best that you can with your calculator. Bring it tomorrow, and we'll grade it, and we'll go over questions on each of the 4, so that by Friday you've taken a full-length AP exam. Sound good? Now, is it smart for you to use your forevers or your notes or anything else on this? So timer, go, and then once the timer's up, put it away and come in tomorrow for questions. Sound good? I want you guys to hand me your 27 essentials as you pick up a packet on your way out the door. Bye. Make sure you just pick up one. David, if you want, you can pick up one for Colby too. That would be helpful. I didn't give it to you early because I didn't want you guys playing with it without a timer going. And apart from notes and people to collaborate with. Thank you, thank you, thank you. It's your homework due tomorrow. Not in Google Classroom, just bring it in attempted. Thank you, thank you. Thank you, thank you. Thank you, thank you. Thank you, thank you. Yeah, I already got it. Thank you, thank you. Thank you, thank you.